Hello everyone, happy to see you here. Welcome back to my channel High Mathematics. Today we have very interesting exponential equation 4 to the x equal to x to the power 4, and we need to find our x. If you have your solution, your answer, you can also write your solution down into the comment section, and then we will check our answer. So right now let's start. First of all, let's apply natural log on both sides. Let's do this right now. So we have natural log on our left side, so we have natural log of 4 to the x equal to natural log of x to the power 4, and everyone should know a really important property. This x will come down right here, this 4 will come down right here. So first of all, we can write it as x times natural log 4 on the left side. So we have x times natural log 4 equal to natural log, or like 4 in the beginning, natural log of not x but absolute value of x. It will be like more correct in our question. The next thing we're gonna do, we're gonna divide both sides by 4x. Okay, let's divide both sides by 4x. I just need to group our variables on the left side and our constant on the right side. So for this, when I divide it, we will have x times natural log 4. We're gonna divide by 4x. And on the right side, we're going to divide by 4x. So we have 4 times natural log absolute value x. We're going to divide by 4x. Right here, we're going to cancel our 4. Right here, we're going to cancel our x. And of course, we will have right here our constant on the left side and our variables on the right side. But we prefer our variables on the left side, our constant on the right side. So I want to change position. So our final expression will be the next one. Natural log of absolute value x. So this one I'm going to write on the left side. It changed nothing. Over x equal to natural log 4 over 4. Right now let's try to solve it. First of all, whenever you have expression with absolute value, you need to consider two cases. When this expression is positive, when this expression is negative. So I'm going to start with the first one. So when x is positive, okay, x is greater than 0. As a result, our expression looks like that. We have natural log x over x equal to natural log 4 over 4. From here, we can easily see our first root. From here, we can easily say that our x first is equal to 4. Okay, we can write it as x first is equal to 4. But this is not the all roots. We can find only one root. Right now, let's try to do some manipulation. How can we find another roots? If you look closely, when we rewrite this expression, natural log x over x equal to natural log 4, we can write it as natural log of 2 square over 4, and right here these 2 will come down right here in the beginning in front of this natural log. So we have 2 times natural log 2 over 4. 2 over 4 we can easily divide, we can easily cancel, we can easily divide each of these values by 2, and as a result we have only our 2 in our denominator. So we have natural log 2 over 2, and right now natural log x equal to natural log 2 over 2. From here we can easily say that our x second is equal to 2, because we have natural log x right here, natural log 2, so we have our second root. X first equal to 4 right here according to this method, and x second is equal to 2. This is everything about x is positive, but of course x can be negative. So let's see what will happen when x is going to be negative. So x is less than 0. As a result, our expression looks like that. We have natural log of minus x, okay, natural log of minus x over x equal to natural log 4 over 4. Right now, let's try to solve this question. First of all, we can write this x in our numerator, but with the negative power, okay? Because when we have 1 over x, we can write it as x to the power minus 1. Okay, and let's write it in our numerator. As a result, we have the same beginning. We have natural log of minus x times x to the power minus 1 equal to natural log 4 over 4. Right now, let's multiply both sides by minus 1. Okay, let's multiply both sides by minus 1. First of all, I'm getting closer and closer to the Lambert W function. So let's multiply both sides by minus 1. As a result, what do we have right here? We have the same beginning, so natural log of minus x. Right here, I'm going to put this minus in this x. So I'm going to write, instead of this x, I'm going to write minus x to the power minus 1. Okay, to the power minus 1 equal to minus natural log 4 over over 4. So I just multiplied both sides by -1, and here we have our minus, here we have our minus on the right side. Right now, instead of this minus x to the power -1, because I'm getting closer and closer to Lambert W function. For those who don't know about Lambert W function, I'm gonna show a few tips how can we apply it. So for example, we have expression like a times e to the power a, and when we apply Lambert W function to this expression, as a result we have only our a. So for example, we have 3 times e to the power 3, we can apply it real quick, and as a result we have only our a, the main only our 3 right here, yeah. But the main moment is to have the same expression right here. We need to have e, and we need to have the same expression in this power of e, okay? And right now I'm going to leave this expression like that without any changes, so the same beginning, so natural log of minus x, but instead of this minus x to the power -1, I'm going to write the next thing, e to the power minus natural log of minus x. When we put this minus right here, because of this natural log, we can easily cancel our e and natural log, so as a result we have absolutely the same thing. So this expression are absolutely the same, okay, equal to minus natural log 4 over 4. So I really hope you understand this, not like change, not like substitution, but we just write it in another way with the e, because we need to have e to apply Lambert W function, okay? And right now, if you look closely, okay, we have natural log of minus x, and we have minus natural log of minus x, but we need to have the same expression. We need to have right here a, and we need to have right here a, but we have minus right here we have plus. So we need to multiply both sides by -1, because we don't have the same powers, we don't have the same expression. So when we multiply both sides by -1, as a result we have the same beginning, so minus natural log of minus x times e to the power minus natural log of minus x equal to, right here we have only our natural log 4 over 4. Okay, and the final tricky move, we're gonna apply Lambert W function, because we have the same expression right here and the same expression right here in these both places. So we're gonna apply it. So Lambert W function of minus natural log of minus x times e to the power minus natural log of minus x equal to, don't forget about the right side, Lambert W function of natural log 4 over 4. Okay, natural log 4 over 4. And right now, when we apply it, we have only our a, but a equal to minus natural log of minus x equal to Lambert W function of natural log 4 over 4. Right now, we need to find our x. We can multiply both sides by -1. When we multiply or divide, this is up to you. When we multiply it, we have only our natural log of minus x on the left side, and on the right side we have minus Lambert W function of natural log 4 over 4. And we need to find our x. How can we do this? We need to create base of e on both sides. So what I mean right now, we need to create base of e. We need to write e of the left side, e to the power natural log of minus x, and we need to create e of the right side, so e to the power minus Lambert W function of natural log 4 over 4. Natural log 4 over 4, and we need to find our x. Of course, right here we can easily cancel our e and our natural log. So as a result, we have only our minus x on the left side. So we have only our minus x equal to e to the power minus Lambert W function of, but natural log 4 I can write as, according to our simplification when we had it in the beginning, we can write it as natural log 2 squared. These 2 will come down right here, so we can change it as natural log 2 over 2. So we had the same thing in the beginning, yeah, you can easily scroll this video back. Okay, and of course the final thing is to multiply both sides by -1, and as a result we will have our answer. So from here our x third is equal to, we have minus e to the power minus Lambert W function. This Lambert W function had a lot of branches, so the correct way to express it is to write n right here, so natural log 2 over 2. And I plug in this expression in a calculator, and of course I can easily write approximately answer, so x third approximately equal to minus 0.7666. So we have our 3 roots right now. Let's write it. So our x first is equal to 4. We had it in the beginning. X second is equal to 2. And x third is equal to minus 0.766. So we have our 3 root. This one is approximately 1. So right now let's check it real quick. In the beginning we had 4 to the x equal to x to the power equal to x to the power 4. Right now let's check it. Let's prove, let's check it. Let's check, for example, x first equal to 4. This is the easiest one because we're gonna have 4 to the power 4 equal to 4 to the power 4. Everything is great. We have the same expression on the left hand side and equal to right hand side. Okay, everything is great. But let's check real quick. Our x second equal to 2, so x first equal to 4 works perfectly, and x second equal to 2. So we have it, let's write it right here. So we have 4 to the power 2 equal to 2 to the power 4. How can I do this? First of all, let's write right here, instead of 2, instead of 4, let's write 2 square to the power 2 equal to 2 to the power 4. And of course, when we multiply our 2 times 2, we're gonna have 2 to the power 4 equal to 2 to the power 4. Or another way to do this, this is our all known values. We have 4 square 16, 2 to the power 4 equal to 16. So of course, when you have like a huge values, you can easily solve this question like that. You need to compare the same bases, but when you have the easy expression like 4 square, this equal to 16, and this one equal to 16 as well, and of course 2 is works perfectly. I feel like this exert is also great. I don't want to check it real quick because we have approximately value, and it's really hard without a calculator. Raise 4 to the power minus 766. So this is up to you. You can also solve this question and write your response down into the comment section. So let's write our final answer to this question. Our final answer, we have x first equal to 4, x second equal to 2, and x third is equal to minus 0.766. Of course, there's the way to solve this question with the Newton's formula. You can easily find this exert with the Newton's formula, but I show you how can you solve this question with the Lambert W function. But this exert can be easily, we can easily find with the Newton's formula. You can easily solve this question. You can easily write your notes down into the comment section. I solved this question with the Lambert W function. You can easily write your thoughts about Newton's formula. How can we find this exert? So right now you can see a graph. You can see these points of intersection. It's really great to see this question like from another angle, from geometric angle. It's also really great to compare both approaches, algebraic and geometric approaches. It's also really great. So this is my solution to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of questions on my YouTube channel, and I really appreciate it when you leave your response. So thank you everyone for your time. Wish you all the best in your life. Take care of yourself and have a great day. See you in the next videos.